So today we're going to be studying a concept called common factoring, okay? Essentially, factoring is basically undoing the expansions that we studied before. So you remember if we had something like this, x plus 2 times x minus 5, we would expand, so you get x squared minus 5x plus 2x minus 2 times negative 5 is negative 10, and you always add the middle term, so you end up with x squared plus minus 3x minus 10. Okay, so in this case, instead of going this way is called expanding. What we're going to be doing is we're actually going to take our information, and what we're going to do is we're going to undo what we're doing to go back, and we call this factoring. So in the next 3 lessons, we're eventually going to be able to go from the final result of our binomial expansion to back to a factored form, i.e. the 2 linear forms, okay? So just remember, factoring is just undoing expansion. So right now, the first thing that we have to understand is a new concept called the greatest common factor. Now, when you hear of something that's called the greatest common factor, what this is the largest number that divides a set of numbers. So, for example, let's try these 3 problems. So, let's find the greatest common factor of each set of numbers. So, here are my sets. All right, so for the first number here, the first set we have here, we have 6x and 24. Now, both of these can be divided by the number 6, right? Both of them can be divided by the number 6, all right? So in this case, you would say the GCF is 6. Now, the reason why they're both divisible by 6 is because both of them have a number in front, but not both of them have an x. All right, so now let's take a look at what would happen if we have numbers that can be divided out, but then also x's that can both be divided out. So if I look at B here, right? B has 10x squared and 15x. So both of these can be divided by the number 5. Both of 5 and 15 can be divided by 5, but each of them have a minimum of an x, so we can actually divide out an x. So in this case, we would say our GCF is equal to 5x. Now, here is the rule. When we have a variable, for all of them, we always take the lowest exponent for our numbers, for our variables, okay? So now let's do the same again for this next one. We have 6x cubed minus 12x squared and minus 18x. The lowest x that we have here is x to the 1, which is just for the 18. So each of these could be divided by x. Now, we're going to look at the coefficients in front. We have -3, we have 6, -12, and 18. And all of these can be divided by the number 6. So let's say all of those can be divided by 6. That's the biggest number that can be divided by them. So that means our GCF is now 6x. And we're done for all 3. So now what we're going to do is we're going to factor binomials by finding the greatest common factor. So now we're going to factor these binomials using the greatest common factor. GCF. Now, the first thing that you have to do for this is you have to find the GCF. And then 2, we factor out. And this is how we're going to do that. So let's say I have the following problem. And we're going to factor this completely. All right, so this is A. So let's say I have 10x minus 15. Now, here is what we're going to do. I'm going to put this in green. So think about it. The GCF of 5 and 10 is 5. So we can divide both of them by 5. Let's do that first. And then here is what you do. So both of them are divisible by 5. So now here's what you do. You actually write 5 times, and you write your equation again, 10x minus 15. And then what we're going to do is divide this by 5 and this by 5. So essentially, we haven't changed the equation yet, but we are going to simplify each term by dividing out 5. So the key is you pull out 5, and then inside we have to divide out the 5 that we pulled out. So let's do that right now. So 10x divided by 5. So you have 5 times the bracket of 10x divided by 5. I'm going to put that in black, is 2x. And then negative 15. So I'm going to put the minus, but then I just go 15 divided by 5 gives me 3. And we are done. Fully factored. So this is fully factored form. So pause a moment, make sense of it. If you have to, revisit this, because I'm about to do the next one, which is factor completely, but we're going to do another problem. So now imagine I give you this problem, 20x minus 12x squared. In this case, the GCF of 20x, each term, and 12x squared is, here it is, drum roll please. Both of these can be divided by 2. No, they can't be divided by 2. The biggest number, they can both be divided by 4, but then we use the lowest power of x. So in this case, x squared is too big, but x is just big enough. So we're going to use that. So we have 4x. So the GCF is 4x. So here's what we write. So we're going to write 4x in front. We're going to put our brackets. Then we're going to copy x minus 12x squared. And then what we do is we divide both of these by 4x. So we put 4x outside, and then we take our original equation that we had up here, and we put it in here, and then we divide each of them by what we're going to factor out. And in this case, when you simplify, you're going to get, start with writing 4x, and then we simplify. So 20 divided by 4 is 5. So we have 5. And x divided by x is just 1, so we just leave it, minus, and now we're going to go and do 12 divided by 4, which gives us 3. And then this is telling us it's x squared, right? And this is x to the 1. So here's what we have to do. We're going to subtract our exponents. We're going to have x as our value, and we're left with to the 1, and we're done. But x to the 1 doesn't really mean anything, so we'll just write x. So think of this part as I've got 2 x's and I'm getting rid of one of them. How many is left over? there's only one x left. So that's how we have 3x. And we're done. Now that is your fully factored form. Let's try this next one. So now we have a word problem. So imagine that you have the following. You know that the area is equal to the length times the width, right? Now, wouldn't it be nice to be able to use our factoring to do something like that? Okay, so now I'm going to give you a problem that I'm going to try out, and we'll do the first part and the second part of our problem. So the liner notes for a CD form an area represented by the binomial expansion of this. So basically what we have is a CD that has this equation for our problem. And what we're going to do is the original box kind of looks like this. The area is equal to 2x plus 3x squared. So that's what they have told us, right? So now we need to write an expression for the dimension of the liner notes by factoring its area. So we're going to factor this thing. And we're going to factor all of the stuff that we have just studied by using common factors. So let's see how we do. So here's the solution. And when we're doing the solution, we're going to attempt to start with the area and then factor it. So the area is equal to 2x plus 3x squared. Now, if I was looking at this problem has a GCF of, the GCF of, let's say, 2x and 3x squared. So both of these, oh, it's not 2x, it's 12x. I apologize. So this is supposed to be 12x squared, 12x minus 3x squared. So we'll just make sure that all this stuff is set up. So you got 12x plus 3x squared. So now here's what we are going to do with that. So you're trying to find your GCF. Now your GCF, the coefficients in front, the 3 and 12, can both be divided by 3. And then we take the lowest power, the lowest x that we have in our terms here. In this case, we have just an x. So we're going to divide by x for each of these. So the GCF of 12x squared, and this is, well, it's just 3x, right? So now when we do our solution for our factorization of a, we end up with 3x being pulled out. We have our bracket. And then what we're going to do is we're going to write our original solution in. So we got 12x plus, I'm going to give myself some space, plus 3x squared. And then we're going to divide each of those terms by 3x. So now let us simplify. So our final answer is going to be 3x times, well, 12 divided by 3 gives us 4. And x divided by x is nothing. And then we bring down the plus sign. And then we have 3 divided by 3 is 1. So nothing. And then we have 2 x's divided by an x, and you're left with a single x. So we end up with 3x times x plus 4. So that means for our graph, we have 3x for one dimension and x plus 4, or 4 plus x, being the other dimension. Now it says, find the actual dimensions if x is equal to 6. So all we're going to do is we're literally going to substitute our information in. So that was A. So let's just make sure that we identify this as the answer to A. So now here is B. I'm going to go and calculate B. For B, I'm going to say that my length is equal to 3x, right? And I'm going to say, all right, remember our x value is 6 here. So we're going to substitute 6 in. So we end up with 3 times 6, which gives us 18. And that is 18 centimeters. So the length in this case is 18 centimeters. And we just say, well, L is 18. So now when we calculate the width is just going to be 4 plus x or x plus 4, doesn't matter. And we just substitute our value of 6. So we go 4 plus bracket 6 gives us 10 centimeters. And so that is our width of 10 centimeters. And we're done. So that's all we have to do for this lesson. All right, for your homework, you're going to do question number 1. You're just going to find the greatest common factor for each of those things. Question number 2, you're going to find the greatest common factor, then find the GCF for B and C. Then you have some more practice for factoring with A and C in number 3. Then you're also going to do question number 6, C and D. Then I want you to also do question number 7, and that's very similar to what we did before. Question number 8 has 2 questions, okay? Try those. And then what I want you to do is I want you to do question number 9. And that's for practice for this. Now, the key to succeeding here is you need to be able to at least do everything up to question number 6, okay? So that would give you somewhere around 60%. 70 and 80%, you'd have to do questions number 7 and 8 on something like this. All right, good luck.